Hello, today we are going to present our project Iotarmor along with my co-presenters Sadhvi Manda and Naga Venkatalu. And the concepts we are going to see, these are the contents we are going to discuss today. Coming to the introduction, IoT is playing a crucial part in the current world. It describes the network of the physical things that are embedded with the sensors, software, and other technologies for the purpose of connecting and exchanging data with the other devices over the internet. In the coming years, it is anticipated that the use of the IoT in various applications would increase quickly. So the research options were increased regarding this. So identifying the vulnerabilities is very crucial, and the idea for this project was inspired by the need to provide a tool that accurately pinpoints the vulnerabilities in IoT devices and provides the workable methods to mitigate them. Coming to the problem, the main problem we face here is finding the vulnerability and knowing its severity. Hackers use vulnerabilities in different ways, such as performing DOS attacks for accessing the data or installing the malware and watching out the passwords and so on. Currently, we are not having tools that can support all the IoT devices and can identify every vulnerability that may cause an issue. So we are going to design, so we need a IoT security sensor tool that is necessary to identify the vulnerabilities and help the user to mitigate them. Coming to the solution, we have designed an Iotarmor tool that works as a security scanner for the IoT devices. It is designed to automate the detection of vulnerabilities and provide the mitigation for them. It scans the IoT devices and mostly concentrate on the following vulnerabilities such as credential stuffing, which means attacker can gain access by using the default or a weak passwords, and firmware vulnerabilities which have bugs in the devices, and network vulnerabilities which may occur while connecting to an unsecure network, which and causes spoofing and interception. And the other are the authentication bypass vulnerabilities and the use of the free vulnerabilities. And this tool can operate through using the ports, and it discovers the devices over the local network, and it will scan all the devices that were connected to the network. It allows the users to view and analyze the results and take appropriate action to mitigate them. It also generates a scanned report that contains the results of the vulnerabilities detected. And coming to the architecture of the tool, this is the architecture of the tool. Here, starting with the engine, it is the central part of the tool. It coordinates with all the other modules, which include sending the inputs from command line inputs to the util module, rerouting the data to the data parser from scanner module, and sending the parser data to the DB module. As we discussed, let's go. The engine will send the input to the util module. It acts as a support module for the engine. The functions of this module are processing and validating the command line arguments. And the library called as ArcParser plays a crucial role in its development. After validation of the arguments, the control goes to the scanning module. The scanning module performs the mass scan, which is a post scanner used to perform the network scans. After scanning, we get the scan results into the mass scan object, which will be sent to the parser or module through the engine. We cannot read a mass scan object directly. It cannot be read by any human. So we send it to the parser module. When we pass it through the parser module, it converts the object into tuples that can insert into a DP and makes it into a readable format. Now coming to the brute force module, we have developed Python classes to perform FTP, Telnet, HTTP, and SSH brute force attacks. These attacks use a word list for the dictionary. Then we try to exploit the vulnerability in the device through the exploit module. Then we send the results to the parser module and finally store it in the database module using the SQLite. The continuation will be explained by my teammates.
Yeah, coming to the control flow of our tool, the control actually starts from user input through the command line from interface of the scanning node, and the inputs are sent to the utils module for parsing purpose and validation purpose. And after validation, then the inputs are sent to the scanning module. Here we perform the mass scan based on the options that we got from the utils module. And the mass scan, after the mass scan is happening, then we store the results. We pass the results and we store the results in the DB, as just Tejasvi said, we will store the results in DB SQLite. So after scanning, we will just think is the device is IoT or not. We'll just guess it, and if it is a IoT device, then we start our brute force process, HTTP, SSH, and TCP and Telnet process, and through some kind of a word list, and we after performing the brute force, we will get some output, we will get some scan results. We will get some results and we will store them in the DB. And after the brute force method, we just exploit some of the vulnerabilities just that shown in the architecture. So we will exploit them, and we will get some results, and we will store the results on parse and store the results in the DB, those results too. And coming to the tools and methods that we have used, mass scan. We are using this mass scan in the scanning module. The mass scan is a TCP port scanner, which the scanning is happening through sending the SYN packets asynchronously to the target. And the mass scan has a type, so many options, but we are mainly using the max rate and the wait time, because wait time is necessary because the tool will stop the execution for some time, allowing the scan happen and the parsing the results. So that's the wait time we are using for. And coming to the brute force, we are performing the brute force methods on the target that are FTP, HTTP, SSH, and Telnet. We are managing some word lists. I will show you in the code. Yeah, these are the kind of weak credentials or the default credentials that every some systems have. So we use this kind of a credentials. So in our brute force methods, and we will brute force and produce some results, and those will be stored in our DB. And and coming to the exploitations, as just as we discussed, we are exploring some of the well-known vulnerabilities, which is, in this particular section, we are concentrating on the routers and cameras, IP cameras. So these are the common, very well-known vulnerabilities that exist in this kind of devices. So we are trying to exploit them and produce some results. Based on the scanning, it produce some results, and we will store them in the SQLite. SQLite is a kind of a relational database management system, which is specifically designed for this kind of a tools. So here, SQLite, we are storing all our end data. And coming to the setup and execution part, we need the Python 3.6 in our scanner node, from where the scanning is happening. And you should install the mass scan in that machine. You can follow this documentation. This is the official documentation of the mass scan. You just have a few lines of the code. Few commands. If you have a good internet connection, I think in 4 to 5 minutes you can install the mass scan easily. So after installing the mass scan, you have to clone our code, which is from this public repository, and you can clone it using Git, or you can download the zip file and unzip it. And after cloning, just you have to enter, go to the directory, and you have to execute this pip3 install -r requirement.txt to install all the requirement, pre-required Python modules for the execution. I will show you that file. Yeah. These are all the modules that are required before the execution of the tool. And after the installing all the Python modules, this fifth step is a optional kind of thing. If you want to alter, if you want to add any some extra uh, username and password to the word list, you can add them, or you can use this as it is that we have mentioned. And coming to the sixth, the execution command. If anyone doesn't know how to use, how to frame the execution command, you just, they have to just simply have to execute this Python 3 IoT armor.py. Just, produce this image which has a kind of a help kind of thing, which displays all the options that we have. Hyphen m means max rate, hyphen w means wait time, hyphen d means the directory, and what are the exploits that we want to give, and what are the brute force methods, and how many threads we want to use while performing the attacks, and what should be the uh, uh, output file that after producing after a scan happening, what should be the output file. So these are the options we have. Below is the example of, this one is the example of some framed command that we have used. This is the target. This target is mandatory. Either you can mention like this one that I have mentioned, or you can give some text file here which contains the one IP or a range of IPs. And hyphen m means max rate, hyphen w means wait time, and we are using all exploitation methods and all brute force with the two threads. And the demo will be given at the end of the presentation, and next the results and the conclusion given by Sadhvi.
Yeah, coming to the result slide, at the end of execution, we get the data into database and we get a .csv file of specific name if given in the execution command. So this picture is just an example of one scan result. So in the next slide, coming to the conclusion slide, we have developed a tool Iotarmor which can scan the IoT devices using IP address. It detects the vulnerabilities and provide information to the user to perform security functions that could mitigate the vulnerabilities. In the future slide, we will discuss about the future scope of the tool in this slide. This tool is platform dependent. It needs Linux OS and Python 3.6 to execute the tool. It is due to the Python modules that we have used while developing supports only for Linux. Now in future we have to make it platform independent so that this tool can be executed from any OS. We can achieve it through Docker, which is an orchestration tool and runs the application in the form of containers. We need to develop the perfect Docker image for the application for that. And in future, if we come across any common vulnerability, then we have to add exploitation of the vulnerability in the tool newer version. Yeah, and that's it. Thank you.
Thank you, everyone.
Thank you.
Hi, welcome to the demo of the Iotarmor tool. Now we will execute the command of Iotarmor tool to execute. Sadhvi, can you execute the command? Yeah. Here we gave our target's IP address in the text file named by target.txt, and we have fixed our max rate as 300, and we are giving the wait time as 20 seconds, and we are using all our exploits, and we are using all brute force methods with the two threads. Yeah. Thanks. So now the mass scan has started since we have a wait time of 40. So now we have to wait for the 40 seconds to complete the scan, and the tool will pass the data. So for the IP address 46.49.43.5, we found that I think 5 ports are open, and now it is trying to now it is trying to brute force that IP address. Yeah, now we have found an FTP default password and default username. Now it's trying to exploit the vulnerabilities. So I think all tests are executed. We didn't found any vulnerabilities in that IP address, and it successfully generated this Iotarmor report.csv. Now we will have the result in the DB too. Now Shad will open the DB. Can you open the scan results? Yeah. Yeah.
Here we can see that the ID, it represents the scan ID, that how many IoT devices were scanned. As per the scan, the ID gets incremented, and the IP address and ports, these are for the target device. And here this column service has running, it contains the port service, and this is a banner, and banner provides us the more details about the service running on the port. By knowing these details, one can exploit the device. And this is how we are storing the passive data from from the scanner into the DB.
So yeah, if possible, can you open the CSV file? I mean, I'm not sure in the Linux system has this support. Can you open it? So yeah. Here is our CSV file with the results. So it is just telling it has a default FTP credentials, anonymous and anonymous. Yeah, that's the final output that we got in the DB, and we will get a CSV file too. Yeah, thank you.
Thank you.